Hello, good morning, everyone.
Good
Uh,
morning.
we continuously have participants coming in, but everybody, whoever is already here, welcome. This is our inaugural session, our inaugural episode for our knowledge series. It's called Smart Saturday Talk. We, as CBPL group of companies, we came up with this initiative where the style of the episode would be 1:1 conversation with experts from industries and academics based on the topics that we have solicited. And we also have a plan in the future to have also questions from you, the audience. And so the audience is there is no restriction on who can join, from academics to industry leaders to shop floor professionals. Even anyone, a common man, can join. And this is awareness session. This is a knowledge series that is intended to help everybody who is listening to us. We are CBPL group of companies. Brief introduction about us for those who do not know. We are CBPL group of companies. We are in operational excellence and digital transformation for operational excellence for the last 25 years, and then digital transformation for the last 4 years. And so the inaugural topic that we thought would be perfectly fitting would be, why do we even need lean and digital, the shotgun marriage of it together? And why does it have to be a shotgun marriage? It doesn't have to be, right? So, of course, we search for experts in this, and who better to start off this session other than Mr. Nital Zaveri. So let me just go through profile of Mr. Nital Zaveri here. Of course, everybody, many here know him as a friend, as a professional, as an expert, as a guru. But to put it in black and white, let me introduce Mr. Nital Zaveri to everybody here listening to us. So he's the managing director of Concept Business Excellence, of course. He's an internationally certified management consultant, a certified Smart Industry Readiness Index assessor, Siri assessor, certified or advanced smart manufacturing from MIT, USA, certified AI mastermind, certified on IoT from World and 4.0 Solutions, USA. So these are his expertise in the digital domain. But as many of you know, for the last 25 years, has exceptional delivery in the field of operational excellence throughout the industrial regions in Gujarat, in India, and abroad. He's a master black belt holder, Six Sigma master black belt holder from Indian Statistical Institute. He has been credited with Consultant of the Year in 2021. So we think it's very fitting that we have Mr. Nital Zaveri with us today. He currently also serves as Deputy Director for the American Society for Quality in the regions of Russia, Asia, India, Australia, and New Zealand, and is also the chair of the ASQ India section. We cannot be more happy than we are right now to welcome Mr. Nital Zaveri to this talk. Welcome, Mr. Nital
Thank
Zaveri.
you. Thank you, Pratyek. And just a small uh, correction is American Society for Quality. Right now, I was the past chair for 2 years. Now I have given the baton to somebody else.
Okay.
And same for the rain region. But now I am actively involved with ASQ for the global activities. So currently, I am serving as one of the committee chair for global ASQ automotive division. Thank you very much, Pratyek.
Okay, that's perfect to know. I mean, that just makes you more fitting.
Thank you.
So our inaugural topic for this inaugural episode is, of course, lean and digital, rethinking manufacturing excellence. So what does so we, of course, for everybody who knows and who doesn't know what lean means, we'd like to start off with basics so that everybody has the same ground level when they're starting or listening to this podcast. So, sir, So we have all heard about, Lean Six Sigma. It has been the benchmark yardstick for operational excellence for like 50 years now. But what does it basically mean? What does lean mean, and where does it originate? We also have some kind of apocryphal stories about its origin from, Japan, where you need to, eliminate wastes so that you can fit yourself in small, where there are space constraints, and there are multiple stories like that. But where does lean come from, and what does it actually mean?
Yeah. Okay. So thank you, Pate, for that great introduction and the great start. And I'm really happy. Thank you, all the participants. This is a very, very important episode for all of us because this is the first in the series of Smart Saturday Talk. You will be having a lot of other interesting topics in the future. So, starting with your question, of course, lean. I mean, I think in the field of manufacturing, this is the word which has been most discussed. You ask anybody, and they will say, "We know lean, and we have practiced lean," or
Or we're
"We
striving
have."
to do lean?
Yeah, exactly. So basically, let me just put a kind of different perspective to the history of this lean, how it has emerged. So let us start from, like we say right now, we are in the fourth industrial revolution, okay, or industry. The industry is in the fourth revolution, fourth generation. Some say it is in fifth generation now, so that's okay. But how the industry started? If you see the pre-industrial revolution era, there, what is the difference? The pre-industrial revolution, there was no machines, okay, and even if there were machines, like let's take example of textile. So there were handlooms. Handlooms were the prime mover. What is giving the power to the energy to the machine was the humans.
Manual
They were manually, putting the this shuttle back and forth to weave the cloth. Okay, so that was the pre-industrial revolution era kind of a thing, where everything was manual. Humans have to do everything. In this era, if you see what industries, all the manufacturing, especially I'm talking about manufacturing industries, even from the pre-industrial revolution era till today, is always trying to improve productivity. This race has never stopped, and it will never stop. The improvement of productivity. So, what was the thought process? Even when in the pre-industrial revolution era, people were trying to improve the productivity, and we know, this concept of time and motion study, right? So, and method study. So, those concepts emerged because people have to do everything manually. So, then the concept emerged: how can we still improve the productivity? So, the concept came like we can do the time and motion study and method study to improve the labor productivity or human productivity, right? Now we go to the first industrial revolution. Now, if you see first industrial revolution, when we started giving the power to the machines using the steam engine and water, okay, hydraulic power. So because of this hydraulic power and the steam power, we were able to move the machine. So the first machine, textile machine that was designed in Europe in early 18th century was using the power from steam. Now, during that time also, even though the machine was running with steam and water or hydraulic power, still a lot of human intervention was required. So still the concept of time and motion shall be still continued even in that era also. Okay. So now we come to the second industrial revolution. So second industrial revolution, when we started thinking about, we had this invention of two important invention of electricity and IC engine, internal combustion engine. So we started using engines and electrical power to run the machines. Now during this time, what happened was there's a concept, and if you see, there are a lot of I would say guru or fathers to this concept. But in order to improve the productivity, what industries were doing, there is a concept which is called standardization. There is a concept called mass production. If you see Frederick W. Taylor and Henry Ford were one of the most discussed personalities for improving the productivity in that era. were mass production. So Henry Ford, when he was earlier, the cars were manufactured like, there is one car and all the operators will come near to that car. They will assemble the car like in a garage you see today. But Henry Ford, when he visited this one of the slaughterhouse, he saw that the conveyor, and on the conveyor they are doing the activities and different processes. So he said, why can't I make car on conveyors? And that gave the birth to the mass production. And then they were able to improve the productivity like anything. But there was a limitation. The limitation was, if you see anybody who is familiar with the lean and the history of the lean, they know there is a very famous saying. It says, Ford in that era, Ford who used to say, we can manufacture any model, any color of car, as long as the car color is black and the model is T, right? Which means you cannot manufacture anything other than black and car model T, right? Because
That's
there is no flex.
standardization right there. Hmm.
Yeah, so there is no flexibility. And that was the problem. There came this person from Toyota, Mr. Taichi Ono, of the engineer. He visited Ford along with other few people. He saw the Ford system because they wanted to manufacture the car. And he saw that this is a very good system. So if you see today in Lean, we talk about the concept of flow, right? Everything has to flow, like information has to flow and material has to flow and money has to flow. The concept of flow was conceptualized from Ford. So we cannot say just, that Toyota is the father of Lean, but, there are a lot of concepts which also came from Ford and other companies also. When Taichi Ono visited USA during that time, he saw superstores. In Japan, during that time, if you want to buy groceries, like there will be somebody will come to your doorstep to sell something like vegetables and milk and all that. They will come door to door and they will sell you the things. Okay, or there are small shops where you can go outside your neighborhood and you buy something from the small shop. First time Taichi Ono saw that there is a concept of superstore in USA in those days also. And he was very impressed by the concept of superstores. You buy the things, nobody is serving you. You just go there, things are there, you pick up the things, and as soon as you pick up the things, somebody will come and put the whatever has been picked up. He liked those ideas. He implemented those ideas, and then he thought of this problem. If I have to do mass production, if I have to make only one car, one model, then I cannot serve my customers, because in Japan we don't have customers who want only one model, because there is a small volume and people want varieties. So use the same concept of mass production, but in a different way. He said, my one car on one same assembly line, if the one car is blue, the next car will be red, the third car will be white, like that. The first car is this model, the next car is another model, the fourth car is another. And it took a lot of time for him to implement this idea. And that's where, and his idea was also the same thing. How can I serve the customer in a better way while maintaining the productivity? Right. So that was the idea. So the element of flexibility was added into the productivity. Right. And that was the core idea of Taichi Ono. And
And I
he
guess
called,
also the element of value creation as well, where he's trying to think about what's valuable to the
yeah,
customer.
exactly. So basically the problem was he thought of a problem from the customer point of view. Is it
Yeah.
okay for my customer to get the same car, same color? He says no. He said my customers want different cars, different models. So how can I adjust my production in such a manner that every car that is being manufactured is exactly as per the customer demand? That was the value creation that he thought. And also in terms of quality and other things also, he has to meet the customer. So if you see that today, in the first time Daiichi Ono came out with this idea, he called TPS. TPS means Toyota Production Systems. So now you see we are moving from time and motion study to mass production to Toyota Production System, right? Now let us move forward. If you see around so we are at kind of a second industrial revolution, third industrial revolution. What happened was we introduced computers, we introduced programs, and computers. People think about computers in third industrial revolution were introduced not only in office. Computers were introduced in machine also, in the form of PLC. right? So we call it programmable logic control.
Yes, not many
So
people have this transparency, but PLC and SCADA is really, third industry
computers, yeah.
I 3.0 technology. Yes.
Yeah, exactly. So what happened because of this computing things, people started using computers in office. People started using computers on the shop floor, right? Uh, what happened because of this computational power is that a lot of productivity improvement happened. Yeah, in both in office and in shop floor. But on this in the shop floor, because of computational power, both the places in office in the shop floor, one thing happened which was like if you see second industrial revolution there was automation but it was mechanical automation
Mechanical.
or
Okay.
electrical automation, right? Electrical or mechanical, like machine will automatically start and stop, or you will put some levers and all that thing so happen make certain things happen through mechanical means, right? But in third industrial revolution this automation went to the next level because the computer can do you can program, and because you can program you can do a lot of automation. So I can build a lot of logics into my computer. I can build a lot of logics to my softwares and my ERP systems, and that increase the productivity like anything. So in that era, if you see, there's this person called James Womack who came from MIT USA, professor, and his team. They started studying Toyota production system again in early 1980s, and they thought why we should call it Toyota production system. We should call it, the word lean is coined by James Womack and his team.
Okay.
They were just discussing in a room and they say what should be the name of this, because this concept is not only applicable to production, it will be not good if you only use it for production, because this can be used in offices also, this can be used by other industries, this can be used in education, government, and all other industries. So when they were thinking, they came out with this idea that why don't we call it lean? And rather than calling it lean manufacturing, in fact, they started calling it lean management. And the moment you say lean management, we are transitioning from production system to management system, right? So that is the entire history of lean. So basic idea of lean is what? So if you see there are 5 steps, what we say, understand what is the value to the customer, map the value. Okay. Ensure that everything is flowing, information, material, money, everything is flowing. And if you see information flow and material flow is like, information flow and money is opposite. The more material flow, more money flow, right? Like that. And the information flow is like a circular flow. So he understood this concept and he created something called VSM, value stream mapping. How do you map this? And then flow, and then there is a, once you create the flow, then you establish something called pull. Pull means you would produce only when the customer wants it. Okay. So synchronize your bank production to the demand of the customers as close as possible. You cannot be perfect, and there will be some waste. Okay. Still today people ask me, uh, in Toyota in lean there are 8 waste, right? One of the waste is so they say, if even if we consider Toyota as example, and if we say inventory is a waste, for example, then any Toyota showroom should not have any car. But the fact of the matter is that Toyota showrooms also have a car. So it's not that there is a zero inventory, but there is an inventory. But you are managing in the supply chain as much less as possible inventory. So you are trying to go as close to the customer's demand as possible. So you have value stream, flow, pull, and then he says, you keep on repeating this till you come to the perfection. The perfection is like never achievable, and by the time you achieve also, there'll be some other definition of perfection. So that's how the lean concept emerged with they popularly call as steamboats, which I think most of the audience also may be knowing. There are 8 waste, and then the entire philosophy works around that. So lean is basically a next lever to the improvement in the productivity. So according to me, the productivity improvement in manufacturing companies has been there since the beginning, even since the pre-industrial revolution. So from time and motion study, we moved to mass production. From mass production, we moved to TPS, Toyota Production System. And from Toyota Production System, we moved to lean management. Yeah.
Yes. Okay. And then somewhere in there also Six Sigma came along, and
Yeah. Yeah, that's I think that's another very important thing, because what happened is, because you have computational power, you have in offices also you are using the computers and softwares, so you have now a lot of data.
Yes.
Now, when you have data, how do you make use of the data for solving the problem? And that's where this concept of Six Sigma help. Actually, if you see the concept of Six Sigma, mainly using like statistical process control and using data analytics for solving the problem, was there since again since the Deming's time. When Deming went to Japan, he propagated this use of all these statistical tools and techniques for this. Later on, Japanese industries gave it a name of 7QC tools. Okay, the 7QC tools again came back to USA, and it was renamed, for example, with additional tools and techniques as a kind of a Six Sigma DMAIC methodology. So that again help industries to improve the productivity. Yeah. So that's the history till third industrial revolution, I would say, and how it links with the lean and other productivity concepts.
Yes, already you have mentioned our the most popular keyword, data. So even when you talk about time and motion study, it's again data.
Yes. Yeah.
And
Absolutely.
when you talk about computational power and logic, it's again data.
Yeah. At
So
100%.
yeah,
Yes.
so you know, if I don't know if people know or not, but data has been a part of everybody's life since long, but it has only been obvious now because of technology. Everybody is talking more about it, and there is more volumes accessible really easily and quickly to us. But so let's get back into this. So when you started and now, how does this conventional or how does manufacturing excellence, how has it changed over the years? I mean, when you started, maybe there were Lean and Six Sigma, the conventional operational excellence, the manufacturing excellence guidelines. People would have had a different perspective on it than they have on it now. So, based on your industry experience, if you can just touch a bit on it, how has the perspective change of the industry for Lean and Six Sigma? Are they more inclined towards it, or is it happening that the trend is shifting away where they cannot find value in it, and because of our shiny toy syndrome, where you need to implement whatever is new, so they are moving towards technology. Is Lean Six Sigma really the foundation on which everything else should be built?
I think very, very important question and point. So there are two things actually. Now, if you see how the transition is has happened, if I see my career of working with all my consultants together with around 1,500 companies, what initially we were looking for in the improvement of companies were like some kind of management systems and some simple productivity gains, for example. With the help of lean, it became very obvious to understand, because you were doing that. It's not that people were not doing lean before that, but the thing is that the it became very clear, it became very obvious for them to understand what is adding value, what is not adding value. It became very obvious for them to identify the waste in the company using the eight waste concept. And there were other tools like value stream mapping, and there are tools like five ways and Kaizen and deep this Pokai, mistake proofing. There are tools like Kanban. So these tools helped industries a lot in order to not only improve the shop floor productivity but overall organizational productivity also. So initially, people were focusing only on the shop floor. That's my perception.
Okay.
They were just looking at labor productivity improvement.
Mm-hmm.
Then they slowly started looking for machine productivity improvement. Then they started, no, no, this is not enough, because even if we produce, still we have inventories lying up in my shop floor. So either on the receiving side or on the outgoing side. So ultimately, if you see that it is not helping, because I get money only when my goods are being received by the customers. I don't get paid when, if I'm a manufacturer, I don't get paid when my inventory is lying in my shop floor. I get only paid when the goods go out of my factory and I get reaches to the customer. So people started improving the productivity and using the lean concepts in the other areas also, in the other activities, okay, like in other processes, in supply chain, the inventory process, and all these things. On the other side, if you see, there is a lot of requirement for almost near to zero defect quality because customer expectations started increasing. So around this time, then people started, initially they started using some basic concepts, let's say in the lean, there is a tool called YY analysis, right? So people started using that to understand, but all the YY tools are all reactive, right? Because you do YY analysis only when the problem has occurred,
Yes.
right? So that's still kind of a reactive approach. Now, what happened was that people started, they said, no, we need something more only beyond YY analysis. So they started using this basic quality tools, because which emerged like as a part of Deming's teaching and other gurus in Japan, like Ishikawa and all that. And then they came out with the 7QC tools, where we have most of the tools, except few tools, are basically talking about visualizing the data, correct?
Yes.
Like if you see SPC or control chart, then you talk about Pareto, then you talk about scatter plot, then you talk about stratification. These are all visualization of the data. Japanese companies were using this, and industries understood this. So if you see, Japanese industries quality improved, productivity improved, the cost came down. So it was low cost, high quality product, which was very difficult for other countries, especially in USA, to compete there. So that is where this concept of, so initially starting with YY, simple YY, and then coming to this basic quality tools, then QC circle. So QC circle also they are using the almost the similar concepts, and right, like the 7QC tools, or they call it 12-step method and all that. But ultimately it is the same. And then people started using this after Motorola and GE started propagating Six Sigma concept, which is a kind of a 7QC tools on steroids. So I would say,
Exactly.
because then they gave it a more all additional statistical tools were added for solving very critical business problems. So that is where the Six Sigma then people started using. But now when I see, then what has happened is, if you see the globally, world over, the research that has been done is says that those companies, so where now if you see, let me just also take you to, after third industrial revolution, now we are in the fourth industrial revolution. Now what is the difference after ERP, after the computers and softwares were used in shop floor and in shop floor and office, right? These two things were not talking to each other. You have ERP system and IT system in the office, you have machine which is running with programmable logic control, but still there are a lot of manual activities which you have. And with Industry 4, what happened is now computers become smaller and smaller and smaller in size. Today, most of the mobile phone that we use is much more powerful than once upon a time, the first supercomputer in the world. We are all
Yes,
carrying a
they're
supercomputer
obediently
in our.
following. Yes, they're obediently following Moore's law. Say every year the rate of transistors, the volume of transistors will increase, the size will decrease. So devices will
Exactly.
keep getting smaller and smaller, but more having more power and
Yeah.
power.
And that's why now you see recent talks in politics and other geopolitical. There is a suddenly now there's a discussion more than I would say fossil fuel or crude oil and other things. More discussion is on these rare earth metals,
Yeah.
because people want to control the manufacturing of this semiconductors and other electronics or stuff, right? So
Yes.
now if you see the sensors and the processors become smaller and smaller, you can even have computer in your heart, okay, in your body also now. So it is now become a very small chip, kind of a thing which can have a huge computational power. And so size has become smaller, cost has reduced, and the another thing which happened was internet, and because of internet now a lot of you can not only just store the data, but you can throw the data into the cloud, and you can everything can emit the data to the internet. Okay. And because of internet now, what has happened is that you can connect all this everything which is there in your manufacturing company. So earlier, what was in silos. The data were in silos in
And
the
the links
manufacturing.
were human. Right now, the
Yeah,
link is
and
technology.
exactly. So the links are now very easy. So there is a seamless flow of data. And because of this now, when everything is connected, it's a like in fourth industrial revolution is nothing but kind of connected factories. Not about automation. Automation was already there in third
Yes.
industrial revolution. It's not about ERP. ERP was there in third industrial revolution. The difference is now connected factory. Connected
Yes.
factory means everything. Let me give a very simple example. The way to explain fourth industrial revolution. There are many
Easy.
ways, but
Yes.
one of the easiest ways for me is to, like today we are going to the highway, we use this toll tax, right? So what happens? My car is going, and there is a RFID tag in my car. This car RFID tag is being read by the system. So it understands which car is coming. It understands my registration number. Then it communicates to the my banking system, and it says whether my bank has this car has some balance or not in terms of money. And it
Yes.
checks, yeah, it's balance. Then the system understands where this car is going, what is the toll amount right now. Let's say $100. Then it understands the $100. It deducts the $100. It puts all these checks and balances. It confirms that this money is received, and then it opens the gate. And everything is happening in a fraction of a second. Because of what? Because everything is connected, right?
Yes.
Because there is so it's a connected world, right? You don't nobody is doing anything. Everything is automated. Even the decision to open the gate or not is not with humans now. You see, the decision to open the gate at a toll is with the computer, right? So
Yes.
same thing is shall happen in the manufacturing industries also, and is happening in the manufacturing. So that's what I think the fourth industrial revolution, and that is where now the industry is, I would say, slowly, gradually moving. Yeah. So people are now, now 2016, the first book was written, Fourth Industrial Revolution by Klaus Schwab. And now we talk about Industry 4.0, 5.0, Society 5.0, and all those things. Yeah.
Yes. So there is this interesting, chronology where the lean principle, Six Sigma, zero defects, theory of constraints, it all emerged from the industrial revolutions and their introduction of different prime movers and energy sources, right? But when the third industrial revolution or the digital revolution happened in the 1970s, which even took astronauts to the moon, that was the era, the Cold War era, where computers and transistors were everywhere, and computers were as big as rooms. And I'm sure everybody must have heard of that key, as big as rooms, super the computers, and So how does that? Is there a disconnect right now between the digital part of it and then the foundational lean? Because when people are moving on towards this, so digitalization was one thing, and then now digital transformation is what the fourth industrial revolution talks about. Is there somewhere in between that people have lost the idea of the foundational lean and Six Sigma? Because even so Deming and Hitoshi Kosune in his books, he writes, the data is where facts start. So data, and then of course Deming's famous quote where he says, "In God we trust; all others must bring data."
Yeah.
So data is where facts start. Data is decisions should be made, and that is the principle of Six Sigma. And digital is helping us in the right way if we use it in the right way, where the collection, the gathering of data is much easier now. In his books, Mr. Hitoshi writes, we take, a week's exercise of collecting data on quality, and that is where he introduces stratification, because the subgrouping part is really necessary for data capturing, because there is no other way to capture data other than human.
Yeah.
Now the collection of data is so fast, it's like 1,000 times faster, so we already have an existing foundation of Lean Six Sigma principles, and now the data gathering, the collection of data, cleaning of data, which is very, very important, we have that. Where is still the where does the disconnect still lie between lean and digital? And if it's there, why is it very, very necessary for lean and digital to go hand in hand?
I think very, very important. Now we understood lean, we understood the fourth industrial revolution and the impact of it, connected factories. Now it's not easy for industries to connect the factories because you have legacy systems, you cannot overnight, replace all machines and then say we will have new machines and new factory. For all those companies who are building greenfield projects, yeah, they have an added advantage if they what we call is as like we also call it smart lean facility design. That's
Okay,
what people are
smart.
doing. Smart lean facility design. It's not only lean design, but it's a smart lean facility design. And so definitely, yeah, it is there. But coming back to your questions, whether so now you see this is I always say like this. It's like this. You have a very fantastic car. You have a, and that's why one of the most popular, most favorite quote or example or analogy that you bring Ferrari. You buy Ferrari, but you are trying to drive the Ferrari in a broken road. It's not going to work, right? So you bring in technology uh, in the fourth industrial revolution. But the technology to work, you need foundation. Now, if you don't have foundation and you say I have a Ferrari, but in India we have the bumps on the road, and the gap, in Ferrari this gap is very less. In the wheel and the road, the gap is very less. It always dashes with the bumps. In USA there are no bumps. Then Germany there are no bumps, so they can drive Ferrari. If you drive Ferrari at that speed in India, you are certain to make an accident. Okay,
You'd have thought it's better
so
to not drive at all.
yeah, and then if you're driving Ferrari at the speed of other cars, or maybe at an auto rickshaw speed, then also it is of no use. So you have to. So if you buy Ferrari, you would like to run the Ferrari at that speed. So lean is like the road or the infrastructure or the foundation. Lean and Six Sigma road. So that's not that is the foundation. So the discussion is not whether we need lean and Six Sigma or we need lean digital. I mean, if anybody is discussing that, I mean, I think that's fundamentally not correct. Okay? Because the discussion should be how can we leverage lean and Six Sigma with digital. Digital is an enabler. Right? On the other hand, if you say there are companies, we have very good basic systems, basic Lean Six Sigma in place. Okay. Excellent 5S, excellent Kaizen system, excellent VSM, all these things. It's like a perfect, it's kind of a replica to Toyota, for example. Okay. But you are not using the new technology. Then also, it's like you have a good infrastructure, but you are still driving a vintage car.
Yes.
So I think that example is very, very important to understand this concept. So lean and Six Sigma is the foundation. It has to be there and it will be there. In fact, now I feel now with the more, like I give another example. We were working for one pharma company and we said we were doing a lean project. One of the very, very large pharma companies, we consulted around 15 plants globally, and they say, we say, what is the bottleneck? So one of the bottleneck was the few machines, okay, the compression machines. And we say, okay, let us understand what is the OE because that's the bottlenecks. We should improve the process. And then we say, and we track the data of this OE. For 3 years, the OE was almost, it improved, but it deteriorated, improved, it deteriorated. It was almost at the same level. We showed them the improvement, though they were internally believing that they had improved. But when we actually showed them the real data, they found that the OE was almost at the same level. Now, why was it like this? Because the employees' time, those people who were in this lean champions in the company, most of their time was going in just collecting the data for OE rather than improving the OE. Right? So I told them, you are practicing lean, but this is anti-lean. If you're
Yes.
wasting time to collect the data, that's anti-lean. It's a muda. It's a non-valuing activity. So
So can
you
you
have,
remind us again, like what are the, just to briefly, like what were the eight wastes for the audience as well?
yeah. So like Team Woods, what we say, transportation, inventory, motion,
Mm-hmm.
waiting, overproduction, overprocessing, defects, and the skill which are not used, right? So, so now the point is, this company, pharma company, wanted to improve, but your time is going in just collecting the data. And not only this, when they come with the data, 5 questions will come on the quality of the data, right? So we suggested them to introduce some system to automatic. How can we use some IoT sensors and other devices to collect the OE data? The OE was 75 percentage initially. Okay. After
Okay.
we put the IoT sensors and data, the
It
number
went
swept.
up.
It went from 75 to 57.
57, yes.
Yeah.
Completely understand.
So that was, they said this equipment is not correct. So he said now the equipment is showing correct data. The problem was earlier you were collecting manual data, it was not capturing a lot of wastage in your company. Now they suddenly see huge scope of improvement in their business. So that is where, now if you see this lean and digital or lean and industry 4.0 are compensating each other. Globally, Bain and Company, Deloitte, there are publicly available surveys where they say those companies who do just traditional lean, they are not able to improve beyond a point. But
Yes, there's a plateau.
companies,
Mm-hmm.
yeah, there's a plateau. Like you improve and then you become stagnant like this.
Mm.
But there are companies, they surveyed the companies who do only lean, and there are companies who do lean and digital together. The companies who do lean and digital have almost close to 20 to 30% more KPI improvement over those companies who are only doing traditional lean. Okay. And these companies who are doing traditionally lean, they were not bad. They were excellent companies. I mean, they have excellent practices of lean. It's not that their lean practices were not correct. But the moment the companies who other set of companies who started using lean and digital together, they started seeing sudden jump in the productivity. And now, if you see globally, what we say something called digital lighthouse, right? The World Economic Forum has
Yes.
come out with this concept, digital lighthouse. I always say, like, if you see now today, from mass production, Ford company to Toyota to Six Sigma to Lean, we are now in Industry 4.0. The companies you should benchmark also should change. Earlier, people were using benchmarking Ford. Then people started benchmarking Toyota. Then people started benchmarking Motorola and GE.
G.
And
Mm.
then now, if you have to benchmark companies, you should benchmark this digital lighthouse company. This digital lighthouse companies, as on date, I mean, as we are speaking, it's around 223 companies globally, which are declared as a having a best practices in the adoption of both
Industry 4.0
operational
technology.
excellence and mainly industry 4.0 concepts, right? Now, these companies, if you see, there are a lot of use cases for there are a lot of use cases for using this, productivity jump. Most of the companies, the data is available on the World Economic Forum website, and you will see from OE to throughput to inventory. I'm just talking lean indicators, right? There are a lot of other indicators also, but I'm just saying lean. In lean, we measure throughput, we measure OE, we measure this inventory. Like these are quality rates. Okay, first time right. All these areas, all these lighthouse companies were able to improve significant. Some companies were even able to improve up to 100%, or more than
Yes.
100%. Some companies, even in some areas, they were able to improve up to 200%. So there is definitely lean and digital should go together, and lean and Six Sigma is the foundation. And on top of it, you have to now use how do we use this together and focus more. So employees' effort should go more on, like you were saying, 7 days just to collect the data and then few days to improve, rather than now we can speed up that improvement process with this new technology. The other thing is whenever you are adopting Industry 4.0, you have to do it from lean point of view. If you just try to digitize everything, if you just try to put technology everywhere, it's not going to help. Technology is not going to solve. I,
Yes.
in fact, feel there are in the digital transformation journey, the operational excellence people or Lean Six Sigma people have a major role to play apart from other stakeholders
Absolutely.
like IT and engineering and other people. These people have a major role because these people have always done one job: how to improve the performance. They know what are the pain points. They know what are the priorities, and you should try and see that how do we get this insight and then do the improvements rather than putting technology everywhere. It's not going to solve your problem if you just try to put technology everywhere, right? So you need to be very mindful of when you're putting the tech. Is it going to leverage your Lean Six
Already
Sigma
existing
capability? Yeah,
capability.
exactly. Then it's of use. Yeah.
Yes, a point to note for those interested. So, Digital Lighthouse, everybody can look it up, or World Economic Forum's page. You can just Google World Economic Forum Digital Lighthouses, and you would be really proud to see there are a lot of lighthouses in India as well, who we can benchmark, and there are case studies available on the site as well. So, now let's like to the main part of the conversation. Since we are talking about industry 4.0, and industry 4.0, as rightly mentioned, it's not just about automation. It's also about connectivity, and then finally the intelligence that comes out of it. Because recently, I guess a few days prior, Sam Altman just said we're trying to sell intelligence to you. So intelligence is now the value driver of the society, of industries. So how so the, and there are industry 4.0 tools and technology. So industry 4.0 talks about interconnection, vertical, horizon, and vertical integration of your processes from your shop floor or your OT integration, and horizontal integration of from your suppliers, your vendors to your customers. So it's a whole interconnected a sphere of manufacturing and value creation, where everybody has transparency, integrity of data is present, and there is value creation, accord human centric value creation, customer centric value creation. For the industry 4.0 technologies that exist, for example, you can talk about right now AI. So robotics also was present pretty early in, or like pretty late into the third industrial revolution, and then pretty early into the fourth industrial revolution. So for text, let's take an example of robotics. So when you install a robotic arm on a conveyor, essentially you're making the process lean by eliminating unnecessary movements. You don't have a human there to have to worry about ergonomics or exhaustions. You have a machine that is just picks up, maybe a conveyor line where it just picks in places. And so in this way, there are a lot of tools and technologies which it complements and it compensates for lean, but it doesn't always come off as that initially. People just think it's technology. So in that sense, what are the kind of technologies, industry 4.2 technologies available for industries right now, which is easy to implement, or which complements lean and Six Sigma in a really acceptable and perceivable way? And what advice would you have for industry leaders going forward who are trying to undertake this journey on digital transformation? Maybe they do not know if you have to have a good foundational experience, or do you just go for the technologies and go for the foundational expert improvement later?
Yeah. Yeah, I think that's very important. So now let me just put it in perspective. Now you see, after fourth industrial revolution, suddenly we now see since 2022 when OpenAI started with Sora, and then later on ChatGPT, and then now there are a lot of buzz going around in the AI, right? Artificial intelligence. Uh, Let me also mention that this digital lighthouse is done in a phased manner. Like every year, they identify some cohorts, group of the companies who are declared as a digital lighthouse.
I
Now,
guess even
recent,
companies can apply themselves for being a
yeah,
lighthouse.
yeah,
Mm.
exactly. So this latest cohorts of the companies who were declared as a digital lighthouse, If you see the surveys and the results, they are very interesting. Manufacturing, it's people think that AI manufacturing companies have now not one but many use cases for use of about use of artificial intelligence in
Yes.
manufacturing.
Yes.
If you take supply chain planning, for example, there are companies who were able to improve the inventory decrease by 15, 10 to 20% according to the World Economic Survey of these digital lighthouses. They were able to use agentic AI to improve the understand the supply chain status. Okay,
Yes.
there are use cases like that.
And it's all
There are
about
use cases.
intelligence, right? Mhm.
So that's happening now because now you have the data. Now, the thing is, people to talk about data, they should have to talk about AI. They should first understand that data is the food for AI. Without data, you cannot. The AI will be just superficial, right? It's not going to work.
And it
And
doesn't has
before
to be, it has to be useful, clean data.
Yeah, exactly. And before that, you should have basic foundational systems like the lean systems, which we talked about, right? If you
That
don't
then
have
gives you
standardized,
the actual useful lean data.
yeah, so you do, and so it depends now for the industries, what is your maturity level? You have to do either first lean, then you go for, connecting the different uh,
Implement.
ITOT and all that stuff, and then you start using AI, or you can start this lean and digital together. That's the depending on the maturity level, right? No problem. But if you see in AI use cases in supply chain management, supplier service level change, like Unilever in India, they automated inventory replenishments using the model which was trained on data such as previous day sales orders, stock
Mm,
targets,
mm.
capacity
Yes.
constraints,
Yes.
regulated product, material availability. And these are based on all this data input, they were able to, precisely, the AI model was precisely able to understand the service levels and their, adherence to that service levels. And they were able to increase that production scheduling now. You see, most of the companies now understanding that the complexity is increasing so fast that you need now not only just ERP systems, but you need advanced production planning and scheduling systems. So there are companies who were able to, use AI for production planning process also. And now these advanced tools which are available can automatically adjust. So first, suppose there is a machine which is down, and then you can also predict what is going to happen to your delivery. And if you give the command to the system, it will
Yeah.
say what you need to do in best manner to manage the deliveries. Yeah. If there are use of AI there, then there is a use of AI in process optimization, like the recipe management, right? So automatically the recipes can or the process parameters can be understood
Also, I guess
by
one of
the
the most popular use cases of AI would be, predictive maintenance because everybody
yeah.
is talking about it right
Yeah,
now.
asset management definitely there. Quality, of course, vision, machine vision, and all that. And like today, we already have one session in ASQ on
Mhm.
how machine vision can be used now. According to me, for example, next 3 to 5 years, based on the surveys which I see, most of the human inspection will go away. The inspections, quality verification will be done by the cameras. Yeah.
And with that, the wastes that Lean talk about will also go away.
100%, because now inspection is a waste or not, there is a debate in the manufacturing company. If you ask them whether inspection is a value-adding activity or non-value-adding activity, so there is a lot of. But the inspection by humans will go away. Even measurement, physical measurement of, let's say, diameter or something like that will go away, or even chemical testing and all that. Because everywhere now machines will be more smarter to measure these things. So inspection by humans will be definitely the humans' job will be to improve quality rather than checking quality now. Okay.
That is the
Uh,
biggest question. With all these technologies now in place, you have, or humans now have, freed up productivity. Now it's high time we realize what to do with that productivity. We should absolutely focus on improving the existing systems with the data and the intelligence we have. So it's like a co-pilot in a sense right now, where human-centric industrial scenario drives this specific perspective.
Okay.
Okay,
Yeah,
so
that's great. That's great.
yeah, Pratyay, we can start Q&A sessions now if we are done.
Okay, sure. We have around 5 to 10 minutes for a Q&A session. Then, of course, as sad as it is, we have to land this plane. We will see you guys. Of course, we'll have next episodes. But for now, yes, sure, we can start with the Q&A session. If anybody, so how are we going to do it, Aditya?
Yeah, I have given everyone to the rights to unmute themselves. They can directly ask, or they can even chat.
So the floor is open. If there is
Yeah.
an open floor right now. If there is any question that anyone might have to Mr. Nital Zaveri, please.
Yes, is my voice audible?
Yes, yes,
Yes,
Ketan bhai.
yes.
Yes. Very good morning to Nital Bhai and the team over there. Very, very good
Thank you.
information. Like गागर में सागर समाने वाले जैसे बात कर दी नितल भाई. Very, very advanced topic in a very small time.
Thank you
Uh,
for your feedback.
yeah. So first of all, thanks to the team. And Nital bhai, just a question to you: if some manufacturing company wants to,
Yeah.
they are having suppose old orthodox style, and they want to go for all this lean manufacturing with the digitalization industry 4.0 concept and all. So what are the various courses, I mean, how and where they should approach? Can you throw some light so that they can get a good consultant and all?
Of course. So yeah, I mean, see, this is if any company wants to do all those things, definitely there are a lot of companies who are consulting depending on the size of the organization. There are many consultants who are working in this space, but uh, right now the problem is one. The problem is there are lean consultants, there are digital transformation consultants. There are very few consultants who can do lean and digital together, because or very few consultants who understand both these together. Most of the consultants will either know lean or they will either know digital, right? So
Or they might also not
preferably,
understand the necessity of it to go together.
yeah, exactly. So then there's a disconnect. Most of the places in the industries, what is happening, Ketan, is that companies are approaching the technology providers. Like today, if I want to measure the OE, I will go and find out who is giving me OE solutions, or who is giving me this predictive maintenance solutions. But before that, you have to do some groundwork. If you go to the technology providers, their interest is in selling the technology rather than solutions, right? So you should maybe have a very good detailing internal discussions, and you should understand from your team also. First of all, you should create your internal cross-functional team which has all the stakeholders, not only just IT or not only just operational excellence, but you should have a very good cross-functional team in digital transformation, not just led by IT team or not just led by engineering team like that. So that's a one very fundamental requirement. And then they can definitely approach a consultant who, I think it is better to approach some advisor or consultant who has seen many factories, or they know both this world, so that they can they are in a better position to guide you and suggest you, rather than just going for separately with lean consultant or separately going with a digital transformation consultant. That would be my advice, and strongly recommended that you have very strong internal team with a very good stakeholders from all different departments with a good teamwork. Yeah, that's a fundamental requirement.
Fine, sir.
Okay.
Thank you so much. Yeah. Thank you
Thank
so
you for
much.
your question, sir. Thank you for your question. Okay, Nital sir, we have another question from Mayank Pandya. I'm asking on behalf of Mr. Mayank Pandya. The question is, Could you share any example of Industry 4.0 and AI in improving financial KPIs of organization?
So see, financial KPIs is a lagging indicator. Okay, because financial benefits at the end of everything happen, right? So finance always is a lagging indicator, right? It's never a leading indicator. Okay, in manufacturing companies. But whatever you see now, I would recommend to visit this World Economic Forum website. Go to the case. There are a lot of case studies published, including the ROI and the payback period of using the digital technologies. And you will see there are most of these tools or which have like Ben and Company. What I said, like what they found in their survey was that companies using lean versus lean plus digital, the OE was up by 15% in the companies who are using lean plus digital together. Now convert that into the financials. It's a very good ROI to the company depending on whether you have the demand or not. Because if you improve the OE but still you don't have any customer demand, you will have excess capacity, but it will not actually result into any financial benefit, even though you have improved, right? So there are a lot of use cases of ROI available. And now most of the companies are smart also. They demand the technology providers. What is going to be the ROI if I put this technology in place? And that is where I said, it is better to use a consultant or a team of consultants who knows both this world, lean and digital together, so that they can guide you on technology. They can also guide you on lean, and they can measure and give you the right ROI also, right? And suggest you right ROI. But there are a lot of use cases of, if you see on using all this. But right now we have to see whether what is it's also you have to, but definitely there are now a lot of other, most of the companies we are seeing a trend now. They are recruiting rather than depending on external agencies. They are also recruiting now. I met few companies recently. The manufacturing companies are now recruiting AI engineers. Manufacturing companies are recruiting this smart manufacturing professionals on their role, automation experts, rather than depending on others. So
That is a really key point to note here. That the very point that you said, that they're recruiting, AI engineers, and it's not necessarily for their enterprise systems, or not necessarily to improve their office or enterprise systems, right? It's to improve their shop floor productivity, and then the shop floor management systems, which is directly related then to the financial implications of that. If you increase in your productivity, your financial KPIs are going to improve one way or the other anyway.
Yeah. So if I just give you few numbers from this World Economic Forum website in India, there are two companies I would cite. One is Jubilant, the other is CA Tires. Both of them are digital lighthouse declared. Jubilant, with the use of AI ML, was able to improve the yield by 1.3%. Now you can imagine in process industries, I think Mr. Ashok Jain is here. He understands Jubilant very well, and he's a chemical person. 1.3% in yield in process industries is it's a huge benefit to the bottom line. Okay. They were able to reduce the scope 1 emissions by using advanced analytics led by for the steam consumption and optimization use of AI. They have declared on World Economic Forum that they were able to reduce this scope 1 emissions by 20%. If I talk about C8 tires, now C8 tires in their they use machine learning for die design, in the die design, and they improved the design time, or reduce the design time by 78%. This is already published data on World Economic Forum website. This I'm talking Indian companies, not foreign companies. Then C8 tire was able to reduce the defects in particular division by using the machine vision up to 57%. Okay. So these are some of the indicators which directly impacts the financial indicators.
Thank you, Nital Bhai. good insight.
Thank you, Mayank sir, for your question as well. So for this episode, our time is over for now. We have to land this plane. Here, I'd like to thank everybody who joined, who gave their presence here for making this a successful inaugural session, and also kudos to the team behind that worked super hard to make this all possible. Last but not least, absolutely, thank you to our guest, Mr. Nital Zaveri, for his gracious.
Aditya, Pratyay, but before this, I would like to thank the entire our Gen Z team. We call it Gen Z team now in our company. So Gen Z team comprises of is led by Pratyay himself. So first of all, thank you very much, Pratyay, for wonderfully organizing this and hosting this. We have Aditya who is managing the show. We have Ayush, and we have and the entire team: Rachna, Anirudh, Nikita, Mansi, and all our other consultants, Ritesh by Social by Devasys ji, and all other stakeholders. So thank you very much, everybody, for this, and special thanks to my Gen Z team.
Yeah. And for the audience, hoping to see everybody back again for our next episode. Hope you guys like this one. Thank you.
Thank you. Thank you.
Thank you. Thank you.